By the end of this video, you will be able to explain what an irreversible reaction and radioactive decay are and what occurs during the process of radioactive decay. You will be able to define parent isotope and daughter isotope and contrast their characteristics. And you will be able to describe what half-life is and how it informs geologists about the ages of rocks.
Well, hello there. So today we're here to talk about popcorn. And we have some popcorn here to help us to talk about geologic time, but more specifically, the ages of rocks, without talking about superposition, cross-cutting relationships, index fossils, and all those things that we use for relative age. We're here to find out about how we determine the actual age of rocks, and popcorn, making some popcorn, is actually a good analog for that. So I have some kernels here. They're representing some of the atoms that you would typically find in rocks, but sometimes in rocks there are atoms or isotopes of atoms, and an isotope of an atom or an element is an atom with a certain number of protons and neutrons. Some of those may be unstable, and an atom that's unstable does not like to be unstable. It wants to change into something that is stable. So the unstable isotope, or what we call the parent, will change or decay in terms of radiometric or radioactive dating, will decay into a stable isotope, what we call the daughter. So the parent, the unstable parent, decays into the stable daughter, all right? And the kernel is the parent, and what does a kernel change into? Popcorn, right? Yeah, something delicious to eat. Much tastier than an isotope of an atom. So the popcorn is the unstable parent, or the kernel is the unstable parent, and the popcorn is the stable daughter isotope. So we are going to put these 12 kernels in here and put it on the hot plate to get that cooking. And while we're waiting for that, speaking of waiting, do we know which of those kernels is going to pop first? Do you know? Do you know? Can you predict which one's going to pop first?
No, I could take a guess, but you can't really know for sure.
Yeah, you think you know?
I have no idea.
No idea. Yeah, we just have no idea which kernel is going to pop first. What are some variables that could affect how the popcorn pops? What do you think?
The heat.
Definitely the heat. What else?
How much time it takes.
How long it takes? Sure.
How many kernels are in there?
How many kernels are in there? Anything else?
The size of the kernels?
Size of the kernel,
Yeah, I
yeah.
was gonna say that.
Size of the kernel, yeah. And how much moisture is actually in the kernel itself. So these are things that are going to change. It sounds like it's getting ready to. And so what happens to the kernel once it pops? Can it ever go back to being a kernel again?
No.
No, definitely not. So this is there we go. Did any of you pick that one?
No.
No? Oh, that's it, you know. So this is an irreversible process. Once the kernel changes into the popcorn, it can never go back to being a kernel. The parent isotope, the unstable parent atom, once it decays into the daughter product, the stable daughter product, it can never go back. This is an irreversible product. See, now they're popping all over the place, and we'll have some popcorn. Popcorn from kernels is very much like radioactive decay. The unstable parent kernel is now changing, and they are going to be popping and popping and popping until they're all kernels, just like radioactive isotopes, unstable parent isotopes in and I think we got one more to go. Come on, there we go. So the unstable kernels, the parents, are changing into the stable daughter product, the popcorn. It's irreversible process. So this is a great analog for talking about radioactive decay. Now, the other good thing about radioactive decay is that we know with certain parent-daughter combinations, we know how long it's going to take for those atoms to change, for those isotopes, the unstable parent, to change into the daughter. We kind of weren't really sure about the popcorn because of the heat, because of the moisture, because of the number, and all those other variables that we talked about. But we know that some parent products, parent isotopes, change into the stable daughter isotopes in a certain amount of time. Half of them will change. Half of those isotopes, half of the parents will change or decay into the stable daughter isotope in a certain amount of time. So if we find uranium-238 and some lead-206, those two pairs of isotopes, they'll be in a certain ratio or percentage, and half of the uranium will change into lead in 4.5 billion years. Some of these half-lives are quite long, which is great for geologists because the Earth is very old and we have very old rocks, and we want to look for these old these very long half-lives of these parent and daughter isotope pairs. Now, one of them is not very old, the carbon-14 and the nitrogen-14. This is a very low half-life, only 5,700 years. This would be more appropriate for dating formerly living things from old civilizations, to get more information on that. So paleontologists would probably, may want to use that, but they're probably more interested in the ages of rocks, using some of the parent-daughter isotope combinations with very old half-lives, especially with rocks that are into the several tens, hundreds of millions of years, into the billions of years for our Earth. So these are some of the parent-daughter isotope combinations and their respective half-lives. The unstable parent product, that was the kernel, and the stable daughter product, there's our stable daughter product, the popcorn, right? Irreversible reaction, irreversible change. It can never go back. These can never go back. Once this decays into that, it's always going to be in that ratio. So, for example, after 700 million years, if we had a combination of uranium-235 changing into lead-207, half of the atoms of uranium would change in 700 million years. And then in another 700 million years, the other half of that half of uranium would change. And every 700 million years, half of what's left keeps on changing. And we're going to simulate that, but we're going to use M&Ms instead. So, half-life, parent, daughter, stable, unstable, irreversible, kernels, popcorn. Yeah, I think I'd rather eat some popcorn than some parent isotopes. Ugh.
When you have finished watching the video, you'll be taking a short questionnaire that will ask you to rate your confidence on a scale from 0 to 10 in performing all of the learning objectives, where 0 is not confident or sure you can do any of the objectives, 5 is fairly confident or sure you can do some of the objectives, and 10 is very confident or sure you can do all of the objectives.